Today I am discussing about the Nobel gas chemistry, that is group 18 elements. First of all, the introduction. Group 18 consists of 6 elements like helium, neon, argon, krypton, xenon and radon. All these elements are chemically unreactive and that's why these elements are also called inert gas. And this Nobel gas have configuration NS2NP6 except helium 1s2. Due to stable configuration of the Nobel gas, these elements are very unreactive. Now we have discussed about the electronic configuration of the Nobel gas. First of all, the helium, which have the electronic configuration 1s2. The neon, argon, krypton, xenon, radon have the valence configuration 2s2 2p6, 3s2 3p6, 4s2 4p6, 5s2 5p6 and 6s2 6p6 respectively. Now we have discussed the physical properties of this Nobel gas. First of all, the atomic radii. When we move from top to bottom along a group, the atomic radii increases from helium to xenon. The radon is a radioactive element. Helium to xenon, the atomic radii is increases. Now we discussed the ionization energy. These elements have stable configuration, that is the NS2NP6 configuration. Due to stable configuration of these elements have very high ionization energy. Very high ionization energy. That is, these elements have no tendency to release the electron. The ionization energy of helium is higher than that of the other elements. Now we have discussed the electron gain enthalpy or the electron affinity. These elements have configuration NS2NP6 configuration, so these elements have no tendency to accept the electron. That is, these elements have low electron affinity. So we have concluded that the Nobel gas elements have no tendency to accept the electron or release the electron, and that's why these elements are chemically unreactive. Now we discussed about the melting and boiling point. The melting point and boiling point is decreases because the melting point and boiling point, the melting point and boiling point is increases due to increasing the dispersion force or London force. Dispersion force, that is London force, are present. Now we have discussed the compounds of xenon. The first synthesized compounds of xenon is Xe plus and PtF6 minus. The PtF6 itself is strong oxidizing agent. The PtF6 itself strong oxidizing agent. It can oxidize Xe to Xe plus and itself reduce to PtF6 minus. The Bartlett first observed the compound and this is the beginning of the Nobel gas chemistry. Now why the xenon complexed with PtF6? It has been observed that the ionization enthalpy of xenon is almost similar with that of the oxygen, and that's why xenon is almost identical with that of oxygen. An analogous reaction might be expected that, and Bartlett reported that the first compound containing a Nobel gas, a red crystalline solid, first believed to be Xe plus and PtF6 minus. Now, many complex of xenon can be synthesized. Firstly, XeF2, XeF plus. Here the oxidation state of xenon is plus 2. XeF4, the oxidation state of xenon is plus 4. XeF6, oxidation state of xenon is 6. And XeO4, where the oxidation state of xenon is 8. So many complex of xenon is synthesized. Now the preparation of the XeF2, XeF4 and XeF6. The XeF2 is prepared on the reaction of Xe and F2 with the proportion mixture 2:1 at the temperature 673 Kelvin. The condition is very important. And XeF4 is obtained by the reaction of Xe and F2 with proportion ratio 1:5 mixture and the temperature 873 Kelvin. And XeF6 is obtained by the reaction of Xe and F2 on the reaction mixture 1:20 at the temperature 573 Kelvin. Now the properties of the XeF2, XeF4 and XeF6 compound. The XeF2, XeF4 and XeF6 is colorless crystalline solid and they are powerful fluoriding agent. Now here we have discussed also the preparation of XeF6. Here the XeF6 is prepared from XeF4 by the reaction of O2F2 at the temperature 143 Kelvin. Now the hydrolysis is very important of the XeF2, XeF4 and XeF6, very important for any competitive exam. All the hydrolysis mechanism takes place by the associative pore. In case of XeF6, on hydrolysis, XeO3 is formed. This is very important. And XeF2 on hydrolysis, the Xe and HF is formed. XeF4 on hydrolysis, the Xe and XeO3 is formed. Now, the reaction of XeF2 with PF5, XeF2 acts as a fluoride donor and so form XeF plus and PF6 minus. Here XeF2 can act as a fluoride donor and PF5 can act as a fluoride acceptor. So phosphorus has vacant d orbital, so it can accept the M minus. Another reaction is here XeF6 can accept the fluoride ions. And here XeF6 plus M is sodium, potassium, rubidium, and here M plus and XeF7 is minus. Now the reaction with the hydrogen, XeF2 reacts with hydrogen to form Xe and 2HF. Here the oxidation state of hydrogen is changed to 0 to +1, and that's why XeF2, XeF4 and XeF6 can act as a oxidizing agent. And this is the oxidizing property of XeF2, XeF4 and XeF6. And now the structure of the XeF2, XeF4 and XeF6, the XeF2 structure is a linear shape and the hydrogen of Xe is the sp3d hybridization. And the two electronegative atoms occupy the axial position and the lone pairs occupy the equatorial position. And this is the XeF4, the square pattern shape, and the hybridization of Xe is sp3d2. And here the lone pairs are situated in trans position. And this is the important structure of XeF6, the distorted octahedral geometry, and the hybridization of Xe is sp3d3. Here the lone pair is present. This lone pair is called stereochemically active lone pair. Due to this lone pair, the XeF6 molecule possesses three possible geometries. One is capped octahedral, another is pentagonal bipyramidal, and capped trigonal piezometry. Due to this geometry, the XeF6 molecule is the fractional in nature. So, the intermolecular rearrangement takes place among the fluorine atoms, and that's why the molecule is fractional in nature. And that is the dynamic molecule, and this is the non-rigid molecule. And next, the reaction of silica. The XeF6 reacts with silica to form XeO3 by three conjugative reactions, and that's why XeF6 cannot be stored in silica. And this is a reason. Here, the partial hydrolysis of XeF6. Due to the partial hydrolysis of XeF6, it can form XeOF4. This is the xenon oxytetrafluoride and xenon dioxydifluoride, the XeO4 and XeO2F2. And this XeO4 and XeO2F2 is prepared by the reaction of XeF6 with silica and XeOF4 with silica respectively. This is the method for the preparation of XeO4 and XeO2F2, and there are also XeO4 and XeO2F2. Sorry, technical problem. And now the xenon oxygen compound XeO3. Previous slide we discussed the XeO3 is formed by the reaction of XeF6 with 3H2. And in here also the reaction of the xenon oxygen compound with silica we have discussed the previous slide. Now this is a genate and pergenate. The pergenate is formed by the reaction of XeO3 with base, and this is the genate and this is the pergenate, and pergenate is formed by the reaction of genate with base. And this is the structure of XeOF4. Here the hybridization of Xe is sp3d2 hybridization, and the shape is the square pyramidal shape. And this is the structure of the XeO2F2. Here Xe is sp3d geometry, and the shape is basically seesaw-like structure. And this is the MO diagram of the XeF2 molecule. Here this is the atomic orbital of Xe, and this is the atomic orbital of the fluorine. The electronegativity of the fluorine is lower than that of the Xe. Now the XeF2 form three molecular orbital. One is bonding, one is non-bonding, and one is anti-bonding. The bonding and non-bonding molecular orbital possesses the electron. And here basically 3C4 bond is formed, one 3C4 bond is formed. But in case of XeF4, the 5 MO is formed, in which 2 is bonding, 2 is anti-bonding and 1 is non-bonding. But in case of XCF6 molecule, 7 MO is formed in which 3 bonding, 3 anti-bonding and 1 non-bonding. And in this case, XCF4, 3 center 4E bond is present, and in case of XCF6, 3C 4E bond is present. This is very important. And now the last, the clathrate compound. Here we have seen that the clathrate compound is formed in between argon and beta-quinol. Here the beta-quinol acts as a host molecule and argon acts as the guest molecule. That here the crystallization takes place and to form the clathrate compound. So what is clathrate compound? The clathrate compound are the compound in which some atoms or molecules which are capable of independent existence are trapped in the cavity of crystal lattice of some organic and inorganic compound. The atoms or molecules are purely trapped, but no bonding is occurred. Only van der Waals interaction is present. The atoms or molecules which are trapped is called guest molecule, and the compound whose crystal structure provide the accommodation of guest molecule are called host molecule. The two factors responsible for the stability of the compound, the one factor is guest molecule are tightly filled in the cavity of the host molecule, and the second point, the guest molecule in the cages at minimum potential energy. Here also important note that helium and neon cannot form the clathrate compound because the size of helium and neon are too much small, whereas argon, krypton and xenon can form the clathrate compound. Next, thank you. Any problem, then if you comment in comment box, and subscribe my YouTube chemistry channel for more discussion.